Hello everyone, my name is Hosmay Lopez. I'm a scientist here at the PhD division, and today I will present to you some of the work that we perform here and to look at the role of the ocean in modulating extreme weather events. And this picture is basically tells the whole story I will present today. What it shows is predictability as a function of forecast lead time, and as you can see, the atmosphere is fundamental in order to be able to predict all the way up to the sub-seasonal timescale, because it's more like an initial value problem. But if you want to extend the forecast beyond your typical weather timescale, it's more like a boundary value problem. You need information from the land as well as surface ocean and under and at depth as well. Some of my colleagues will present as well. So if you like your weather forecast, thanks an oceanographer. If you want to extend it. So, but we're not only looking at the typical weather forecast, we're also looking at the role of the ocean on extreme weather event. And today I will present some of the work regarding heat waves and why we care about heat waves. Well, heat waves are on the rise, and they're projected to continue increasing to the future. And they are the #1 weather-related cause of death in the US. And here I'm highlighting two deadly examples, 2011 and 2012 Great Plains heat waves. And why they're so deadly? Well, this is the 2011 heat wave, and you can see heat waves are the only weather phenomenon that's extreme, large scale, and long time persistent. You can see for the 2011 case, it persisted basically throughout the entire summer, and it covers a large portion of the country. That's why fatalities are very high associated with these events. And our work here in the division demonstrated that we cannot characterize heat wave like one specific event. We have to characterize them based on regions. And what was found was we created a product which is known as time of emergence associated with climate change with regard to extreme weather events. And what was found was anthropogenic climate change will dominate the occurrence of, will be the main driving factor of heat wave occurrence in the Western US and Great Lakes region and Northeast, whereas natural variability is still dominating the occurrence of heat waves, even in the most pessimistic climate change scenario for the Great Plains regions. So we want to understand what's driving this large natural variability in the Great Plains. And that's a study we found recent that teleconnection patterns associated with the East Asian monsoon, which is shown in the top left panel, can actually produce this teleconnection pattern across the Pacific North American teleconnection pattern, which can actually modulate heat wave occurrence over the Great Plains. You can see that for the strong monsoon, you have more likelihood of extreme heat waves in the Great Plains. And this is very important because also a study from our division shows that the MOC, as other colleagues mentioned, we monitor the MOC because it influences weather. Well, this is an example. We found that the South Atlantic MOC is an indicator modulator of global monsoons, Northern Hemisphere monsoons. So when the MOC in the South Atlantic is weak, at about 20 years lead time, you experience a strong Northern Hemisphere monsoon, and that's because of interhemispheric modulation of the Hadley circulation, as you can see in the schematic diagram. And how does that links back to the heat wave? Well, this is a composite of the number of heat waves as composite based on the state of the MOC. So you have a weak MOC, you have more heat wave in the Great Plains, and that's linked back through the monsoon. So MOC modulates the monsoon modulates the number of heat waves in the US. And we also look at other extreme weather events, tornadoes, which along with heat wave and flooding are responsible for the most deaths. And we want to extend the tornado forecast beyond your mesoscale timescale. And this is a great example of a study performed here in the division, where these global patterns of sea surface temperature in the ocean are responsible for tornado outbreaks in the US. And what you can see here is mostly a trans-Nino pattern, where you have a strong sea surface temperature anomaly in the tropical Pacific, which can lead to atmospheric teleconnection and modulation of wind shear and moisture transport into the Great Plains of the US, which then can induce more tornado genesis. And this is a model, this is under developing here in our division, which look at seasonal prediction of tornado outlook based on those SST patterns that I showed you before. And you see that the model has a very good skill for the below normal conditions and the above normal conditions. where the model issues much higher hit rates than false alarm rate, which is what you can see here in the bottom panels. We have no skill in the near normal conditions, but that's typical of any statistical model. We also not only working on the seasonal timescale, but also on the subseasonal timescale for tornado outlooks. And this is an example of current work performed in our division, which links the MJO to tornado genesis in the Great Plains through this very nice schematic diagram. And I want to summarize. We show the physical links between the state of the ocean. Well, I'm out of time, but well, the ocean is important for extreme weather event, heat waves, and tornadoes. And with that, I want to introduce the next speaker, Renelis Perez.